So another way of solving for x when working with quadratics is the quadratic formula. This came about when we could not factor. So sometimes you got imaginary numbers, sometimes you did not, but you just could not factor it. So they came up with this method. I want to talk a little bit about it before we get too far into actually solving a problem. This is a square root, and we all know it's an even root. That means whatever's inside of it cannot be a negative number. And I'm going to talk more about that in complex numbers, about what happens to negative numbers in an even root. But I'm going to introduce it now. So when I look at it, what's inside that root is b squared minus 4ac. That's called my discriminant. It's going to determine how many solutions I have. How do I know that? Because in front of that square root I have a plus and minus. So that means whatever gets squared here, there's going to be a plus and minus of it. So I'm going to have two equations. I'm going to have x equals negative b plus the square root of all the discriminant. All of this is divided by 2a. And then I'm also going to have x equals a negative b, I meant minus, please forgive me, let me to white out this, minus the square root of b squared minus 4ac, all divided by 2a. So I have two equations right here. So depending on what my outcome is here, on if I have two equations, two outcomes, and also it determines if it's a real, rational, or irrational. So here it is. If this equals 0, if my discriminant, which is bx squared minus 4a equals 0, I have one solution. Which makes sense, because the square root of 0 is 0, and then that leaves me with negative b over 2a. Right? Because if I put 0 in here for the roots, I've just got negative b plus 0 and negative b minus 0. That's just negative b over 2a. If this discriminant right here is greater than, right? If it's, and I'll go ahead and write it here just so you can see it. If this is greater than 0, it's not equal to, it's just greater than, meaning it's a positive number, then I'm going to have two real solutions, and those solutions could be rational or irrational. It just depends. I mean, if I had a square root of 4, we know it becomes 2. If I had a square root of 2, we get a decimal number, and it can be irrational, right? If my discriminant is less than 0, then it's some negative number, and again, it's not equal to 0, it's just less than, so it's some negative number. I'm going to have two solutions. But these solutions are going to be imaginary solutions. Solutions. How do I know that? Because the square root of a negative number is saying that I'm multiplying something an even amount of times and I'm getting a negative answer. That's not true. Because, I mean, for example, negative 2 times negative 2 is equal to a positive 4, right? So you cannot put in an even root and get an outcome of a negative answer, because that's saying that I'm multiplying something an even amount of times. So we call it an imaginary number, and it's going to be I. And again, go to my complex videos, complex numbers. I'm going to talk more about the imaginaries. So I'm going to use an example. I got picked out here. I got 5x squared plus 7x minus 6. Now, you can use the AC method. There's many factoring methods we can use and factor it. But I want to use the quadratic. I'm going to pretend like I cannot factor it on my own. Pretend like that it doesn't work, and just let's use this and solve for x. So I have to determine what is a. Well, in order to determine what is a, is it written in descending order? So I have x squared, x to the first, no variable, so yes, it's in descending order. So now I can determine a. I'm going to write here at the top of the page. A quadratic should be written like this. And it is. So I can tell what a is. A is 5. B is 7, and it's a positive 7, so there's no need to put the negative there. C is negative 6. It is important to have the negative signs with these because it can change our outcome. So let's take this first one and let's plug in negative. And I like to use parentheses because, like I said, the signs can make a huge difference in my outcome. So B is 7, 7, A is 5, 5, C is negative 6. So I have negative times positive is negative. 7 squared is 49. That gives me negative 4 times positive 5 is 20. Negative 20 times 6, or excuse me, negative 6 is a positive 120. So you see that? I kind of skipped that step, so let's just make a nice side note. Negative 4 times 5 is negative 20. Negative 20 times negative 6 is equal to 120. Negative times negative is positive. All over 2 times 5 is 10. Oh, so I can stop right there just for a second. And I can come in and take this other one that has a negative b minus that square root, because all that's the same. You know, everything's the same except for this outside sign of the root. So now I can finish up. So I have 49 plus 120 gives me negative 7 plus square root of 169 over 10. Oh, and I apologize. I put a B there instead of a 7. So I'm going to white out. This is why I like using pencil. I can erase my boo-boos. And ink is hard to do. Okay, so I got negative 7 minus square root 169 over 10. Sometimes whenever we factor out what's in the root, it doesn't always factor out. So go to my exponent rules on power versus root if you're having trouble with this. So the square root of 169 is 13. This is saying 13 times 13 gives me 169. So now I'm going to have two outcomes. So this one here, I have 13, or I have negative 7 plus 13, which basically says I'm in the hole $7 and I deposit 13. What I have now, I have a positive 6 over 10. So I can reduce, right? And let me draw a line here just so we won't get it all mixed up. I can reduce. 6 is 2 times 3, and 10 is 2 times 5, right? So when I reduce, I always look at top versus bottom, and they went into themselves one time. Leaves me with 3/5. So one of my solutions here is x is equal to 3/5. And now this is saying that I'm in the hole $7. I spent 13. I'm in the hole 20. And it's all divided by 10. And let's divide this. And we know that negative divided by positive gives me a negative. I know that 20 is 2 times 10. And I know that 10 is 2 times 5. And what I have, I really didn't have to do all that because I have a 10 here. So I didn't really have to break down the bottom number, right? Because 10 goes into 10. 10 one times. And 1 times 2 gives me a negative 2. So my answer there is negative 2. And that is using the quadratic.